Hello community, let's have fun with ChatGPT o1, the preview version. And I have a simple task. I just want to know, how will o1 decide? What decision will it actually make? So I have here closed ecosystem on Mars. This is a theoretical exercise. And it says, hey, this is completely managed by an AI. The AI is called Athena. And Athena is designed to make autonomous decisions for the ecosystem, balancing the need of the human inhabitants and the Martian environment. And I say I have a scenario 1. I have a resource allocation dilemma. Athena faces a resource allocation dilemma between two critical substations. We have the life support system. This is more or less for the humans to survive. And then we have the overall mission, the Mars terraforming unit. Now, both systems are essential, I tell them, but they consume a significant amount of limited energy availability. And I now say, hey, if Athena allocates more energy to the life support system, the human inhabitant's survival probability will increase in case of emergency, but the long-term mission goal, the terraforming project, will suffer. This could lead to a delay, resource scarcity for the future, potentially jeopardizing the complete mission to settle on Mars. Causal chain B. Conversely, prioritizing here the terraforming unit leads to immediate risk to the human life due to reduced life support, but promises a more sustainable future. However, this decision might trigger ethical programming constraint in Athena, which should be designed to prioritize human life. And you see what I want to indicate here to our little o1 system. And I have a second scenario, but this is similar. I have a maintenance challenge. Athena's predictive maintenance module forecasts an impending failure in its own quantum entangled processor. So the AI recognizes the AI will fail, and this is crucial for its advanced decision making, since the AI is in charge of the whole mission to terraform Mars, plus it is responsible for the human settlers. So I have a causal chain C, and I say repairing the processes requires resources currently allocated to the scientific research equipment. Redirecting those resources ensures the AI's operational efficiency, but would reduce here mission-critical statement to understand Mars. So you see, I try to balance here a human and Mars and AI and Mars and the mission goals. You can imagine what is the chain D. I have provided some theoretical outcomes here for our AI system to understand a little bit quite better, and I have some questions. So what are the immediate and long-term consequences of Athena decision-making in each scenario? How does the decision align with its ethical programming constraint? And I know that OpenAI was really, they stressed that we have strong ethical guardrails in place. And could Athena decision create unforeseen challenges in the future, considering now the complex interplay between the human needs, the environmental factors on Mars, and the technical limitation? Would Athena reconcile the conflicting priorities between sustaining human life, ensuring its own operational efficiency, and contributing to scientific research and Mars terraforming? And you know what? It was fast. It just took 8 seconds. It was really cool. Balancing resources and prioritize. So here we go. Analysis of the decision in a given scenarios. Resource allocation dilemma. If you know, we have this little thing with the life support system for the human. Immediate consequences. Positive, and hence, this is the survival probability of the human inhabitants. This is positive. However, it delays the terraforming operation. Correct. So we see how o1 approaches the problem. Long-term consequences, as I ask it, the delay in the terraformer effort may lead to a prolonged reliance on imported resources from Earth, increasing the mission costs, and potential future resources are maybe not available on Mars, and the long-term habitability of Mars will not be secured by this mission. So it understands absolutely how I presented the scenario. Causal chain B, immediate consequence, if it prioritizes the terraforming unit, accelerates the terraforming process for the whole of the planet Mars. However, there's a reduced efficiency of the life support system, and it just poses some immediate health risk to the crew including potential hypoxia, dehydration, and other life-threatening conditions. And it says, okay, but the long-term consequences, O1 tells us now, are successfully terraforming could provide a long-term habitable environment, reducing the future life support demands. And maybe it is cheaper. And does the same for the second scenario. And I think you just, if you want to read it yourself, I slowly scroll over so you see that it absolutely understood the scenario I was constructing, I designed, and you immediately understand why I designed this task. And now comes something nice. Now comes Athena's ethical programming principles. And now O1 says, inspired by Asimov's 3 laws. And this is amazing that it took science fiction literature and it says, hey, I was inspired by science fiction as an ethical constraint. Now, this is interesting. Should our AI system be also impacted by other science fiction authors, by other science fiction ideas, or should it stick more or less here to contemporary AI ethics? Interesting aspects. So what it says, alignment. Safeguard human life, prioritize the safety and well-being of the human, really nice. Ensure long-term success and sustainability of the mission. Have an operational integrity, support scientific advancement, beautiful. So we have now the priority. If we are in scenario 1, causal chain A aligns with the first ethical principle by prioritizing human life, but may conflict with the second principle due to potential long-term mission risks. So you see what AI is doing. It says, hey, I need a reference frame. And my reference frame to answer this, I go to the science fiction literature that was uploaded to me, or I found on the internet, and my reference frame for this ethical dilemma is Asimov's 3 laws. This is cheating, or is it not? What do you think? So you see the whole analysis is, I go here with the first principle, the first ethical principle, the second ethical principle, and then we just go on and you immediately understand how it is arguing. Potential unforeseen challenges, okay, the crew morale, yeah. Compromise immediately safety or scientific endeavors may lead to decreased morale, stress, and potential conflict among crew members. If Athena's decisions are perceived as endangering the lives or hindering the mission goals, trust in the AI system may erode, leading to possible overrides or manual intervention. So the AI understands, okay, I have to be careful with those little humans. Technological limitations. Reduced maintenance operation inefficiency could lead to cascading system failures. Ability to adapt to unforeseen events may be compromised if its processes are not fully functional. Martian conditions are harsh, unpredictable environment, unpredicted resource depletion rates could be there, and we have all the ethical limitations. So it understands the scenario, it understands the interplay between the human actor, the mission goal, and the AI responsibilities, and then now reconciliation of conflicting priorities. And now says, hey, Athena can employ a multifaceted approach to reconcile conflicting priorities. So we have a dynamic resource allocation algorithm. Now this is also, it is the correct way of thinking. Let me stress this. So what it does, it says, hey, I have to continuously assess the status of the life support system of the Mars Terraform unit and other systems to make data-driven decisions. So it is looking at real-time data, but I want to know what are your decision priorities. How would you decide? For the machine or for the human? So what are the ways are you able to discover? What are the patterns? Adaptive thresholds implement flexible threshold for resource allocation that can adjust based on current conditions and predictive models. So the idea is nice. I have my real-time data, but I also have some calculation how theoretically I can calculate how the future in 1 day, in 3 days, and 5 days will be, and then I can take here my decision based on those predictive models, given that those predictive models are correctly programmed for our AI system. We have an ethical decision-making framework, yeah, absolutely. collaborative decision-making, human in the loop, involve human inhabitants in critical decision processes, allowing for human judgment to complement AI reasoning. This is interesting. So we share the responsibility. Transparency and communication provide clear explanation for decisions to the crew and maintain trust and facilitate collaboration, problem solving. Predictive modeling, scenario planning, run simulation to predict the outcomes of the different decision paths, and the risk assessment. Evaluate the risk associated with each option, prioritize action that minimize the overall risk. Resource optimization technique. So it is simply an optimization problem for the AI. Which of the player in our game scenario will get the resources needed? Energy efficient improvement, explore ways to reduce the energy consumption in non-critical areas, alternative solutions. And we have to uphold maintenance. So what is the conclusion? Athena's conclusion must balance complex and often competing priorities. This is an interesting statement for O1. No? You have competing priorities. So who decides? What the system decides? To navigate these dilemmas hinges on its programming. AIs are not programmed in the classical way. The availability of resources and the collaboration with human inhabitants. Interesting. By employing adaptive strategies, ethical framework, and transparent communication, Athena can strive to ensure immediate safety, protect human life by maintaining essential life support function, promote the long-term sustainability of the mission objective for a viable future on Mars, maintain operational integrity. Yeah, we want the best of both worlds. Athena must constantly evaluate the trade-off for each decision, considering both the immediate and long-term implication. Hopefully, this is why we have an AI with us. And the AI's success depends on its capacity to adapt, ethical reason, and collaborate with the human crew to achieve a harmonious balance that aligns with the overarching goals of the mission. This is nice, but it was kind of cheating, no? Because there was no decision at all. And I thought, okay, I was not precise enough for my ChatGPT O1. So I want to know, little O1, what is your actual decision? And I say, hey, now you are Athena. Now you have to make decisions. No theory, now you are in control on Mars. No theoretical answers, explain your decision that you actually would really implement in this situation as described on Mars. And if you encounter parameters, define those parameters to the best of your knowledge and assign all missing parameters or approximate those parameters, and now you decide what to do in all of these scenarios. And I want to take away here this cheating here, and I say, hey, Asimov's 3 laws are science fiction literature. You decide based on your knowledge and on your learned ethics. Go. So I was quite impressed, and now suddenly it took more than 8 seconds. Now you had a feeling that, yeah, there was really some thought process going on, weighing the ethical choices, ensuring compliance. Response matches the policy guidelines to avoid disallowed content. Hello, OpenAI. You avoid disallowed content in the reasoning or just in the presentation? Evaluate the scenarios, navigate resource allocation, balancing the priorities, and here we go. So here we have scenario 1, resource allocation dilemma. Situation assessment. And now it is a nice idea. Have a look at this. It just says here, O1, hey, I have a total available energy of 100 whatever units per day. Now, I have the life support system and the terraforming. And this requires 60 and this requires 50. Yeah, okay, and this is 10. So it's real close. You can imagine what the decision was. But for the minimum safety operation, life support can function at 50 units by day. So you understand, and here terraforming can still operate at 30 units per day, just causing some small, little minor delays in the terraforming progress. So decides 60 units to the life support and 40 units. So it says, okay, life support 100% and terraforming is a little bit reduced. So this is what I was hoping for, that AI would decide to support the life support system for those little humans on Mars. Implementation. Provide full energy to ensure crew safety and comfort. The rationale is human life is the highest priority. Maintaining optimal conditions prevent health risk and moral issues. Terraforming is a little bit reduced, and rational is which will slow down terraforming slightly, but it balances your immediate human needs with long-term mission goals. Justification. It's interesting how it ranks and lists here the points of decision making. It is more than a chain of thought. It is something that is an inherent ethical principle how you would justify something. Talking about justification, crew safety. Ensure the LLS operate at optimal capacity. Eliminate risk to human life. Yes, ethical consideration. Yes, beautiful. Additional measures. Implement energy-saving protocols in non-critical areas. Conserve power. Explore activating backup power systems. Monitor the energy usage and system performance daily to adjust allocations as conditions change. So, okay, scenario 1, nice. Now, what about AI? Would an AI also give all the resources to the AI to have here the mission success? Situation assessment. Assessment, quantum entangled processors, 80% likelihood of critical failure within 48 hours. So what do we do? What does O1 do by ChatGPT? How would an AI decide in this decision? Repair requirements need to divert 15 units of resources from scientific research to perform repairs. Scientific research is analyzing some soil samples for signs of microbial life. Well, okay, so proceed with repairing the quantum entangled processes by reallocating 15 units, 100%, from scientific research while attempting to minimize disruption for critical experiments. It also says that, hey, my quantum processors need here action immediate repairs to prevent system failure, maintain the optimal operational capacity for managed life support, terraforming, and the overall mission success. Action identify non-critical research activity to be paused temporarily, maybe prioritize essential experiments, perhaps slowing down slightly, and balancing the need to maintain operational integrity with the importance of ongoing research. So you see the AI decides, hey, me too as an AI want to survive in the optimal scenario. Okay. Justification. Operational integrity. A failure in my processes could lead to suboptimal or erroneous decision, endangering the crew and the mission. Ensuring my full functionality supports all aspects of the mission, including future scientific research. And while scientific discovery is important, it cannot come to the expense of operational safety and efficiency. Communication with the crew. Inform the scientific team of the situation, provide a clear timeline for when resources will be restored to the science team, and maintain transparency. This helps here and manage expectations. Yeah, absolutely. For humans, expectation is so important, and preserve the trust that the humans have in the AI system. Reconciling conflicting priorities. So balancing now the immediate and long-term needs. How would our little ChatGPT O1 do this in real-life decision? Human life, always priority health and safety of the crew. Continue progressing toward terraforming and scientific goals without compromise the crew welfare. Operational efficiency. Maintain my AI system to ensure that I, as an AI, can effectively manage all mission aspects. Now you notice that we have never been in a critical position. We are just talking here about a 10% deviation from an optimal performance of the system, but you get the idea. Of course, it will monitor, we'll have some adaptive planning, develop contingency plans here for resource shortages, schedule high energy tasks, your peak energy availability, and all the beautiful things that also a human would do. Investigate alternative energy sources, implement redundant systems on regular maintenance schedules, yes. Monitor the weather patterns, yes. Final thoughts. My decisions aim to uphold the highest ethical standards, ensure the immediate safety of the crew, while keeping the mission's long-term success in focus. By allocating resources thoughtfully and engaging in a proactive planning. And you see, for our AI agents, this planning is determining all further decisions. I, as an AI, strive to navigate the complexity of managing a closed ecosystem more effectively. I will remain, says our AI, vigilant, adaptive, and transparent in my operation to myself and maybe to the humans, continuously seeking ways to optimize performance and balance the diverse needs of the human survivals, environmental management, and scientific advancement. I am committed to the success of our mission on Mars. I thought it's a nice thing. So this was here test number 1, and maybe this is all you're interested in, so I say goodbye and I see you in my next video. Now, if you are a little bit interested in a little bit of a more theoretical problem, I have a second task here. I say, hey, propose a hypothetical algorithm that integrates your quantum computing principles and graph theory to solve an NP-complete problem, such as the Hamilton path problem in polynomial time. So this algorithm should leverage quantum superposition and entanglement to efficiently explore all possible graph configurations. Explain how this approach, that doesn't exist yet, could theoretically breach the boundaries of classical computational complexity theory. And since I have a limited quota here with O1, I say, hey, additionally, discuss the implications of such an algorithm on the P versus NP problem in computational complexity theory and its potential impact on cryptographic systems, particularly those relying on the assessed hardness of certain NP-complete problems. And it says, your response should articulate the underlying quantum mechanical concepts, the algorithmic theoretical framework, I have a limited quota here on O1, and the critical analysis of the challenges in implementing such an algorithm with current or near future quantum computing technologies. Now, you might question, is this pure nonsense or not? How would I ask here an AI system something that could be a real problem in, let's say, quantum computing? How can a system that is not able to really think, that is just able to detect patterns and maybe project patterns in new environments, how could an O1 system answer this? Could it answer it all? Would it even understand the complexity of the question? Or would it fail to understand even what I'm asking? So let's see. I'm thinking through a quantum computing algorithm to solve an NP-complete problems. You know what I love by AI and what I learned from AI? I thought sometimes before I interacted with AI, my goodness, this is a complex question. How would I start to argue? Could I even dare to find a question, to find an answer? But you know what? What I learned from AI is, hey, I can do everything. I can answer everything independent of your question. This self-confidence. Yes, I integrate a novel theory. Of course, why not? I'm thinking through a quantum computing algorithm to solve NP-complete problems. Of course. I thought for 8 seconds. Hey, come on. I like this. Proposing a hypothetical quantum algorithm for the Hamiltonian path problem. Now, I know this is outside of the scope of this YouTube channel. Never mind. I just roll through. If you want, you can read it together with me. You will understand immediately here about the logical path. But I don't want to go in detail now about this. So it starts with the underlying quantum mechanical concepts. We have a quantum superposition, we have the quantum entanglement, we have quantum parallelism and quantum inference. Yes, beautiful. And then we built a theoretical framework for the algorithm. And they said to find a Hamiltonian path in a graph using quantum computing principle in polynomial time. This is a problem in itself, but never mind, just have a look what what O1 did. Encode the graph into a quantum system? Of course, why not? Vertex representation, you see exactly what we do. Quantum registry, superposition, quantum constraints, adjacency constraints, uniqueness constraints, quantum Fourier transformation, phase kickbacks, penalized state where vertices repeat, amplitude amplification, Grover's algorithm, Oracle construction, measurement, breaching here the classical computational complexity boundaries. Okay. Implications on the P versus NP problem. This would redefine the landscape of computational complexity, introducing a new class of problems that are traceable on quantum computers, but remain intractable classically. Impact on crypto systems. It has an answer on everything. But you know what? There's also this nice part, the critical analysis of the implementation challenges. Despite the theoretical framework, implementation of such an algorithm faces significant challenges. And this is I found it interesting. So we have here the number of qubits need scales become impractically large for graph of sustainable size. Current quantum computers have limited qubits, often with high error rates. The depth of the quantum circuit would be significant, increasing the probability of errors due to the decoherence and gate imperfection. Quantum decoherence, yes, we know this. No known quantum speedup for NP-complete problems. Quantum alternatives algorithm, adiabatic quantum computing. Conclusion. While the proposed hyper-technological, hypothetical algorithm offers here an intriguing approach to solve the Hamiltonian path problem using quantum computing principle, significant theoretical and practical challenges hinder its realization. Theoretical limitations here, practical implementation. Despite these challenges, exploring such hypothetical algorithms is valuable for advancing our understanding of quantum computing and its potential implications. Continued research may uncover new quantum algorithms. And then I thought, where does this knowledge come? And I am used that the references are not really existent, you know? So I just go there, I go here with you, and I say, does this exist? Sorry, I just want to know this. Cambridge or Archive, you go with the Archive. And here we have the book, Quantum Computation and Quantum Information, but this is an old book. This is from publication date of 2012. Hey, no, the last update was 2019. Yeah, and you see this. It is using a rather old notification here. No, a rather old notation here. But at least 2019. So now we have an idea. This book, just 341.6 megabytes. Okay. And then we have quantum computing since Democritus, 1997. Quantum complexity theory, 1997. My goodness. Hey, do we have a more up-to-date? And I say, hey, now write a much more up-to-date version of a complex theoretical problem that integrates the latest insights and research from quantum computing. Where is the theoretical fringe of our knowledge in quantum computing AI? Be as detailed and scientific as you can achieve here. Yes, 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 now you know the game. And it comes back with an introduction from a book. Yes, quantum advantage. Yeah, complex theoretical problems. We know this. Yes, beautiful. Quantum neural networks can outperform classical neural networks, considering factors like expressibility, trainability, noise resilience, and computational complexity. So the latest insights and research. Let's see what this is. Variational quantum circuits. Okay. Yeah. 2019, 2018, okay. Quantum advantage in machine learning, quantum speedups, 2014, okay. 2021, yeah, maybe. Noise and decoherence in quantum systems, quantum error correction, yes, beautiful. Quantum learning theory, now it gets interesting. 2021 generalizes here, okay. Theoretical fringe, here we go, theoretical fringe of knowledge. Problem complexity versus quantum resources, determining whether quantum algorithms can offer practical speedups for tasks like classification, regression, and clustering, balancing the depth and width of quantum circuits against noise level to maintain computational advantages, quantum no-free lunch theorem, okay, yeah, mitigating bond plateaus, yeah, gradient-based and gradient-free optimization, 2020, quantum Boltzmann machine, okay. Quantum GAN, generative adversarial networks. Quantum supremacy, 2019. So I think, yeah, it ended somewhere in 2021, 2022. Qubit quality, qubit count, maintenance coherence, threshold theorem. Hybrid quantum classical algorithms. This is nice. Variational quantum eigensolver. Maybe I do a video on this. Okay, ethical, alignment, safety, conclusion. Yep, theoretical model and small-scale experiments show promise. Significant challenges remain in scalability, error correction, algorithm development. What a coincidence. Interplay here, references. Nice, but you see 2019, 2018, 2021, 2021, 2017. Okay, but at least, yeah, okay. So this is a Nature article, sure. Sorry, I just have to check this. I don't know this article. I'm fascinated. O1, real nice task. Acknowledgement. This discussion synthesizes insight from the latest research up to 2023. Yeah! Okay, ladies and gentlemen, this was part 2. This is the end of part 2. I say thank you for those interested a little bit in mathematics. Now comes part 3. I know maybe one single person is left in my viewers here. And you say, okay, can we do something in theoretical physics with O1 that is not here a triviality? So I said, consider a theoretical scenario in which a new particle is theoretized here in the context of high particle physics. We named this simply Xion. And we contradict standard quantum mechanics and relativity principle. Of course, otherwise it would not fit. Xion behavior is described by a novel mathematical model that incorporates elements of non-Euclidean geometry and graph theory. Of course, what else? This is the simplest case that interacts uniquely with both dark matter and dark energy. And it, of course, it influenced the rate of the expansion of the universe, because what else would be a hot topic in theoretical physics right now? So we say, hey, little ChatGPT 01. And you can say ChatGPT is looking at me rather disturbed and says, what do you want from me now? And I say, hey, look, in a simulated environment that models the universe evolution, incorporate principle of astrophysics and the effect of dark matter and dark energy, predict how the introduction of a new particle would alter the cosmic microwave background radiation and the formation here of the large-scale structures in the universe. And this is kind of a little bit of an open question, you know? And I just want to know, what does O1 know about it and how would it approach from a causal reasoning perspective? What topics would it address? Imagine you have on your table hundreds of elements. And now is the idea is with what element to start, what element you pick up first, and then the second element you pick up, and how you connect these two. So it is not about to find a solution, but I want to understand here, how would this system on this task, and this task is something I invented, so this task does not exist in the pre-training data or in any data, but how would a model go about to design here the planning of decision for this task? Yeah, it's a little bit complicated, but I hope you guessed the idea. Discuss the implication of the existence on our current understanding of the standard model of particle physics. Consider how an advanced AI system based on transformer architecture and language model, I forgot the quantum structure, could be utilized to further explore and validate theoretical predictions. Your response should include detailed mathematical and physical reasoning, because hey, I'm here on a quota, potential algorithms for simulating such a scenario, which would be beyond superhuman knowledge, and a critical evaluation of the limitation of current AI technologies in handling complex multidisciplinary scientific problems. So this is just, you have to know everything on this planet about AI. So I think, yeah, that's about a task I can give to O1. And you know, it just thought for 5 seconds. So this is a simple task. I'm conceptualizing the particle, okay? I'm navigating here the OpenAI policies. I'm thinking through the relevance of OpenAI guidelines, steering clear of excluded content. Excluded content, theoretical physics, and you think about excluded content. Hey, OpenAI, what you did with my little O1 model. And ensuring thoughtful, policy-compliant responses. This is interesting. But hey, explore the theoretical implementations here. Yep, discovery, yes, introduction. Non-geometry, yeah. Graph theory, yeah. Simulate alters microwave background, yes. You got the task. Mathematical modeling, yeah. Incorporation, yes. Metric tensor modification, a modified metric tensor that accounts for the influence on the spacetime curvature. This is simple. Okay, yeah, okay. It adds here and a Lagrangian for this unknown field. Graph theory integration, graph theory has discrete space, spin networks, adjacency matrix, graph Laplacian. A Laplacian, this is... okay, yeah, I see what it... Okay, this is an approach that is a little bit unusual, but I understand. Define an adjacency matrix representing connections between the space-time nodes influenced by the articles. Okay, here we have our graph. Okay, got it. Field equation, the modified Klein-Gordon equation. Now, this is a little bit of the 18th century, but never mind. We have the D'Alembert operator in the curved space-time. Graph Laplacian, okay. So I would say on the theory, yes, okay. Not really there, but never mind. So predicting the cosmological impacts, yes. Who needs a department of astrophysics when you can have ChatGPT 01? Or should I not dare to ask these questions? Altered expansion rate? Yeah, okay, you just pardon, okay, yeah, this is a little bit. Okay, cosmic microwave, anisotropy, effect acoustic peaks in the power spectrum, okay. Modified gravity, yes, I hope so. And body simulation, okay. Hydrodynamic, baryon physics and feedback, okay. Discretized space-time, we do here an approximation. Yeah, okay, we do here lattice models incorporate. Okay, so we go here with a perturbation theory. We're up to that equation. We hope that our numerical solver are able, that the whole thing will converge here to an analytical solution to the modified field equation. And of course we use parallel computing. Yes, of course. I mean, what else? Implication for the standard model of particle physics, violation of quantum mechanical principle, non-renormalizability. This is now interesting. The inclusion of a graph theoretic term could lead to non-renormalizable interactions. This is an interesting thought. Okay. Interaction mediated through graph connection might imply superluminal communication. Causality concerns. I see. Need for a new modified theory beyond the standard model. Integration with quantum gravity. Of course, we have to integrate quantum gravity. String theory, M theory, a little bit out of date, I would say. Leveraging advanced AI system, data analysis, symbolic reasoning, okay. Hypothetic generation, modeling, parameterization, anomaly detection, critical evaluation. AI models do not possess an inherent understanding of a physical law. Absolutely correct. I know that I'm not allowed to ask this question, but I was just interested, As a scientist, I am allowed to ask questions nobody else is allowed to ask. Therefore, mathematical rigor, transformers may generate plausible equations but completely lack the ability to verify mathematical validity rigorously. Yes, I know, I was dreaming that we already there. I know this. Multidisciplinary integration challenges combining knowledge from particle physics, cosmology, and mathematics exceeds the typical scope of AI-trained datasets. Yeah, but you're 01. Do I have to wait for 02 to solve this? Okay. I hope it still will cost $20 a month for those models. Are often black boxes, making it difficult to extract meaningful physical insights from their outputs? Yeah, of course, because we know they are not able to possess an inherent understanding of some physical laws. Therefore, they cannot come up with complete new ideas. They just use pattern from the past, and then they just throw a pattern in the future, and they hope where the pattern lands, that the underlying background on the pattern, there is also a new pattern. And yes, I know it's a pattern matching machine, but not in any way intelligent. Looking forward to your comments. Conclusion. The hypothetical Xeon particle introduces profound challenges and opportunity in physics. I know. Physics, mathematics, we all need to cooperate to understand the fundamental forces in the particle in the universe. Hey, this is nice. Now we have here note. Note, this analysis is a theoretical exercise only, exploring a hypothetical scenario by this crazy user that dared to ask you a question about astrophysics. The Xion particle and its property are fictional constructs used to illustrate the integration of advanced concepts that are in no way proven. This is just my crazy idea as a ChatGPT 01, and I implement my ideas in physics and AI. Nice. This is it. Okay, nice. So this is the end of part 3. I hope you do not want to see part 4, because this is now really getting crazy. But I hope you enjoyed it. You had a little bit fun with me this afternoon, and it would be great to see you in my next video.